Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Green Tech Today is provided by Cachefly at CACHEFLY.com.
This is Green Tech Today, the Twit Network's Top 25 Green Tech Innovators Series. This episode of Green Tech Today is brought to you by the Eco-Imagination Challenge from GE. GE and its partners are awarding $200 million to ideas that help build the next generation power grid for the 21st century. For more information and to view and comment on ideas, go to ecoimagination.com/challenge. And by audible.com. To download a free audiobook of your choice, go to audiblepodcast.com/greentech. You might be familiar with the idea of the Bush-era hydrogen economy, using hydrogen fuel cells to power your car. Well, that future has not come to pass, but fuel cells are still making substantial progress in the commercial sector. UTC Power is a leader in creating fuel cells that produce efficient, combustion-free energy. We were able to check out one of UTC's recently installed fuel cells at St. Helena Hospital in St. Helena, California, and discuss why a fuel cell was a good energy choice for the hospital. We're at the St. Helena Hospital in St. Helena, California. This hospital is the first hospital in California to install a UTC Power fuel cell. This is Neal Montany. He's the Director of Stationary Business for UTC Power. Neal, can you tell me a little bit about the fuel cell that has been installed here?
Yeah, sure, Kiki. This is our Pure Cell Model 400 fuel cell. It's 400 kilowatts of electricity. It's a CHP, combined heat and power type power plant. Okay. And it's used to power the hospital. It provides about 63% of the electricity needs of the hospital. And it also uses the thermal energy that's created through the fuel cell process and to heat and the building and also hot water for the building.
Wow, so the fuel cell really is doing a lot of work for the hospital's energy needs, not just electricity, but much more than that. Much more than
electricity. That's where these fuel cells really make their benefit to the customer. We provide the electricity, but our fuel cell, during the normal process of the fuel cell, it generates electricity, heat, and water. And we capture that heat, and we use that heat in many different ways in buildings to either heat the building, cool the building if they have an absorption chiller, also for domestic hot water, and it can be used for space heating, things like that.
So what are some of the challenges and things that you really need to consider when installing fuel cells for a business or for industrial application?
There's a lot of factors to consider. Fuel cells are a relatively new technology in this type of environment in consideration when you compare it to the grid. Fuel cells have been around for a long time. UTC Power has been working on fuel cells for 50 years, but we're trying to get into a market where you're talking about an electrical grid that's been in place for a long time, and we need to find an application where first it's a fit for the product. We need a customer who has a high energy need and a high use for the heat. So 24/7 they have a need for the electricity and the heat, and that allows the fuel cell to provide them a better payback and a value proposition. We also need to be in the right location where we run off of natural gas. Obviously the competition, so to speak, is the grid or do nothing, and we need to make sure that we put the fuel cell in an installation where it will provide a payback for the customer through having a gas price and electric price that is a good match for a fuel cell installation.
A lot of installations that we're seeing now they're being subsidized by state subsidies. Is that one of the ways that's one of the things that's allowing these fuel cells to be adopted more readily?
Absolutely, absolutely. We rely on not just UTC, but other fuel cell companies rely on both state and federal incentives in some cases to allow the fuel cell to be installed. This is a relatively new technology, and again, in comparison with the grid, and we need this type of funding to get the business started. It will help generate volume, and volume will generate discounts, and then you can get the technology to a place where it will be affordable without the incentives, and that's what we're trying to do and we strive to do every day. This product has been very successful, and it's only been launched for just less than a year, and we've sold nearly 60 units, and we're really excited about the future and the potential opportunity to commercialize this business.
What are some of the innovations that this product it has in terms of fuel cell technology? What are you doing to move the market forward?
This fuel cell is phosphoric acid technology. Phosphoric acid technology has been around for a long time, like many of the other technologies in fuel cells. UTC Power, we've worked on every different technology. The key attribute about the phosphoric acid technology is it's a proven technology. In our Model 200 product, which has been around since 1991, we've sold...
And that's a 200 kilowatt
that's a
product,
200 kilowatt product. That was the predecessor to the Model 400. And we have, we've sold, between the two models, we've sold over 300 units worldwide, 19 countries, 6 continents. And the reliability, the durability, and the overall lower cost of ownership is what really makes this product and this fuel cell type to be what we consider to be the industry best, because it does have, this product here has a 10-year stack life, and that is industry best. And when you look at the life of the fuel cell and the cost of a fuel cell, obviously a large chunk of the cost is in the stack itself.
Right. How long is it going to last, and when are you going to have to replace it?
Exactly.
Yeah. So right now, stationary, we're looking at large installations mostly. Any idea about the household fuel cell future? When are we going to be getting when will I be able to get a fuel cell in my house?
You probably can today.
If I had a big enough wallet, yeah.
If you're willing to pay for it. We at UTC Power are not playing, so to speak, in that market. We've done a lot of work in that market. It's down at the 5 kilowatt or below size, and we've done some work there, and we have done a lot of research and development. But right now, that's not a core focus for us. It's really, it may be in the future, we'll look at that, but right now it seems to be a little farther off relative to the economics and making a commercialized business out of that.
Coming up, we're going to go down into the belly of the beast to see the fuel cell that St. Helena Hospital has had installed.
We're partnering with 4 of the biggest venture capital firms in the clean energy space, 3 in the US, 1 in Europe. Again, we think that the combination of GE investment and venture capital investment is going to allow us to increase innovation. It's going to allow us to accelerate new ideas. It puts us shoulder to shoulder with some of the smartest tech investors, and we can use what I would call the industrial clout of GE to bring technologies to this marketplace faster.
GE announced its challenge at a San Francisco event along with its 4 venture capital partners. Emerald Technology Ventures, Foundation Capital, Kleiner Perkins Caulfield & Byers, and Rockport Capital Partners have all joined with GE. Ideas from companies and individuals can be entered through the ecoimagination.com website for the next 10 weeks. So check out ecoimagination.com.
All right, so behind us right now is the fuel cell. It's amazing. I'm standing here talking with Stan Tempchin. He is the Director of Facilities at St. Helena Hospital. Stan, this quiet fuel cell, how does this compare to old energy-producing generators?
Well, it's way more efficient and a lot quieter, and it's just much, much better. You know, we investigated looking at diesel generators as a cogeneration process. You know, cogeneration, one fuel produces both heat and electricity.
Okay.
We looked at micro turbines, we looked at large turbines, but the fuel cell was the most efficient, and we could place it near our hospital here without it disturbing the hospital. And we're built on a hillside, and there aren't many places for us to put a fuel cell or a
any kind of
turbine or any kind of generator. So we're very pleased to have it.
What were some of the other considerations that you took into account when you were considering
whether to get a fuel cell for the hospital or not?
Well, we looked at the economics, of course. That's the first consideration. Looking at small turbines, didn't pencil out for us in terms of either the electric or the heat that we needed to utilize. In order to make a fuel cell really pay for itself, you need to use all the electricity if you can, and you need to use as much of the heat as possible as you're putting the fuel cell in process. The large turbine we looked at, the smallest one was like 1.2 megawatts, and it produced way more heat than we could possibly use because we're not a huge hospital.
Right.
The micro turbines didn't work out. Diesel generators are old hat. I mean, you know, they're not that efficient, and we couldn't utilize them. This had a nice balance, 400,000 watts. So it was,
which is a good amount of energy.
Good amount of energy. We can use 100% of the energy 100% of the time. And the heat produced by it is not too much for us. So we can utilize as much of the heat as possible. Right now we're utilizing 87% of the high grade heat that comes off of this and only 16% of the low grade. But we have plans to utilize more. So
yeah, you have other plans for the hospital in general in terms of energy efficiency. Can you name some of the things that you're planning on doing in addition to adding the fuel cell?
Well, we want to utilize more of this heat, of course, to pre-temper outside air that's coming in. We have a therapy pool we're going to be putting in. We want to use this to heat the therapy pool. We have, as I mentioned to you earlier, we have a water supply and distribution system at the hospital. It's unusual for hospitals, but we have one. Yeah. And we have a 700-foot fall from our primary water source to here. We're looking at putting in a 25,000 watt generator.
Wow.
Because you have to slow the water down as it comes down rather than using pressure reducers. We might generate electricity. So we're trying to keep green as much as possible. Of course, keeping green means you're spending less energy and you're saving money. That's a great goal.
Yeah, can you tell me about some of the energy savings and the financial savings that you're going to be gaining from this fuel cell?
Yeah, when you install a fuel cell, as with a turbine or when you install a cogeneration plant, period, once you've paid for your upfront cost, your biggest risk is your fuel factor. So in this case, we're burning natural gas to make electricity and heat. And our natural gas contract is the risk that the facility takes, because for 10 years, 20 years, we'll be buying natural gas. And of course, the market fluctuates up and down. So right now, our savings should be about $190,000 a year with our current natural gas contract.
Okay, that's substantial.
Very substantial. We're looking at about a 3-year payback on this. Of course, that's due to the generosity and the foresight of the state of California with their self-generating incentive program rebate of $1 million for this. Plus, we had a $500,000 donation from an anonymous donor. So between those two, that made this a very, very viable project financially.
Yeah, very viable. And in terms of offsetting carbon emissions, so this is not a combustion generator. You're not emitting all sorts of. You're not burning fossil fuels. It's natural gas, but you're not burning petroleum to be able to power something. What kind of savings are you getting in terms of carbon dioxide emissions?
Oh, this is tremendous. And in fact, I think you're aware a fuel cell on straight hydrogen emits only water.
Right.
That's it. So burning natural gas has some emission. I think we're saving 530 tons of carbon monoxide, and I can't remember all the details of that, but this is very, very green compared to the electric grid in general.
Right.
Very, very green. So
yeah. So is the big savings the fact that you're not pulling power from the grid that's been fossil fuel, coal or oil generated, but rather that you're generating it here in this?
Well, actually in California, a lot of generation is natural gas. But by the time they generate electricity and the waste heat is not necessarily used somewhere, so they're generating electricity, then they have to wheel the electricity, step it up, wheel it from point A to point B to our doorstep, and then we take it. By that time, the efficiency is about 30% on the grid. This, you can get up to 90% efficiency. So it's a huge difference between the potential of having your on-site generating and taking something from the utility company.
Great. Well, can you take me on a tour of the setup so I can see what you've actually put in here?
Sure.
That'd be good.
So this is the fuel cell itself. The fuel cell is similar to an active battery. So you put You know, a battery stores up energy, and you get energy out of it, and you have to recharge it. In this process, this is similar to a battery. It's got an anode and a cathode, but in this case, you're putting natural gas in, so you're creating the power continuously in the fuel cell. This is the natural gas coming in that powers the fuel cell. In the state of California, we have a 39-cent decatherm discount that comes off of the transportation costs for going green. That's only available for certain projects that you put in, and the fuel cell qualifies for that. So we have a natural gas meter that will be metered by Pacific Gas and Electric that and as you can see, it's not hooked up.
Tells you how much gas you're using.
How much gas we're using, and they'll give us that discount.
Right now, it's free.
It's free. Well, actually, we're not saving just yet, but we'll be measuring. And that's a earthquake valve we put in. So if there's an earthquake, this automatically turns off the gas, and then it regulates it down and goes into the fuel cell here. The fuel cell gas goes through a process with water where the protons and electrons are separated. The electrons go on a certain route and create the 400,000 watts of electricity generated by the fuel cell. The byproduct is heat that comes off, and the heat is coming out of the fuel cell in the form of hot water. This area here has the hot water coming out. There's high-grade water supply. That's water that comes out at 250 degrees.
Really hot.
Very hot. It's not boiling because it's confined to a pipe. Then there's the low-grade heat, and that comes out at 140 degrees. So every hour, this is producing 1 million BTUs of high-grade heat and 750,000 BTUs of low-grade heat. That hot water goes
and that heat is all a byproduct of the process.
It is. It's all a byproduct, so to speak, of the process. And so the more of this we use, the more efficient our utilization.
Because less is going to waste.
Exactly.
More is going to what you're actually consuming.
So in any kind of cogeneration plant, you use whatever heat you can, and the rest of it goes out the stack. This is no exception. On top of this building adjacent to us is a big radiator that's part of this fuel cell. It's kind of like a car radiator, but on a giant size. Any heat that's not utilized in our hospital buildings goes to that radiator and is just blown out into the atmosphere. So the less of that, the better.
That will be less and less and less over time.
Right, right, the more we apply. So this heat goes through a series of pipes. We have a couple circulating pumps here. We have a circulating pump for the high-grade heat, circulating pump for the low-grade heat, and these pumps are on a variable frequency drive. What that does is the variable frequency drive is tied into an energy management system, and it tells the system tells the variable frequency drive how many gallons a minute we need to be flowing through here, and it slows these pumps down or speeds them up according to the exact need of the system. So if we're not using very much heat, it'll slow the pump way down to say 50% of its normal speed, or it'll speed it up as the need changes.
As it increases or decreases.
Right.
Nice.
So then the heat comes out of the pumps through these two loops, a high-grade heat loop and a low-grade heat loop, and it goes into the building and is tied into various heating systems within the building. It heats our domestic hot water for two of our large, one 5-story, one 6-story building, produces all the domestic hot water, and then it supplements our heating hot water, which runs at about 190 degrees Fahrenheit. So this 250 degree water goes through a heat exchanger, heats up our heating hot water loops, and is circulated through our buildings to provide space heating. So, yeah.
And how much of the, currently how much of the hospital is utilizing?
Well, we have we have two 5-story buildings, one 6-story building, which is the hospital buildings proper. Then we have some outbuildings. We're heating two of those buildings, one 5-story, one 6-story, providing all the hot water for 3 of our buildings. So
nice. And so this is expected to take you through the cold winters.
No problem.
Not that California gets super cold, but you're not expecting any kind of problems with the heating needs.
No, we in fact in the wintertime we're obviously going to use more heat than the summer. So
yeah, and in the summertime, what will happen with the extra heat that's not used in the summer when
it gets rejected through that cooling tower
Okay.
Right.
It's pretty cool.
It is. It is. It's very simple. And you can sit here and talk. If you've ever been near a turbine installation,
Yeah, we wouldn't really be able to.
You wouldn't be able
have
to
a
talk.
conversation.
no. Pretty noisy. So,
This is great.
yeah.
Well, thank you very much. This has been really interesting.
You're welcome. My pleasure. Yeah.
This episode of Green Tech Today is brought to you by Audible.com. Audible.com is a leading provider of audiobooks with more than 75,000 downloadable titles across all types of literature, including fiction, nonfiction, and periodicals. For listeners of Green Tech Today, Audible is offering a free audiobook to give you a chance to try out their service. One audiobook you may consider downloading is Cradle to Cradle, Remaking the Way We Make Things by William McDonough and Michael Braungart. To download this audiobook for free or another one of your choice, go to audiblepodcast.com/greentech. That's audiblepodcast.com/greentech.
That's it for this episode of Green Tech Today. I'm Dr. Kiki, and I'm done green hunting for this week, but you can find me someplace new and exciting next time.
That's it for this episode of Green Tech Today. Subscribe at twit.tv/GTT and never miss a show. If you have a question or a comment, email us at greentechtoday@twit.tv. Or you can leave a voicemail at 415-GT Today.